Good day. Today we're going to be talking about applications of piecewise functions in the real world. Now, I'm going to show you numbers 3 and 5 from today. And because I believe practice is one of the best teachers, your assignment will be to do the other 3 problems. So, number 3. For a piecewise function in the real world, you have to consider the real world domain restrictions on the problems. You plan to sell t-shirts as a fundraiser. The wholesale t-shirt company charges you $10 a shirt for the first 75 shirts. Okay, $10 a shirt for the first 75. This is the first piece of a domain because if I buy 75 shirts, I'm being charged $10 per shirt. This is a linear model, $10 per shirt. So I want you to notice my x values in the function I'm about to write, f of x, is the number of shirts. If x is the number of shirts, the y is going to be the cost. All right, now, if up to 75, that means I can include 75 in that initial domain. So x is less than or equal to 75. Now, the problem does not give me more than this, but I want to ask you a question. Is this statement, as it is written, currently accurate? The answer is no, it is not accurate. The reason is, if x is just less than 75, it could be negative 20 shirts. You cannot buy a negative 20 shirts. So what is the lower bound? The lower bound is 0. And 0 is less than x. Technically, you could put or equal to. My personal theory on this, you don't buy 0 shirts, you just don't buy anything. So I like that being a less than. If you were to put a less than or equal to, I would be okay with that, but personally, I do not like it. There is the first part of my function. Now let's continue reading. After the first 75 shirts, you can purchase up to 150. Those are my new extrema for the domain. After 75, up to less than or equal to 150. The company will then lower its price to $7.50 per shirt. Well, I am certain you may start by writing 7.5x. However, this is incorrect. Here's the reason. If it is just 7.5x, then I'm not including any of the shirts I've already purchased up to this 75, nor am I getting charged at all for 70. So more or less, I can buy 70 or get 76 shirts. I could buy one and get the rest free. That is what this is telling me. Okay, this is obviously incorrect. So how do we fix that? Well, first, we need to take off the 75 shirts we previously bought. So I'm taking my x, the number of shirts, and I'm subtracting the 75 from the first domain constraint. Well, that's not all, because I need to know how much money I have already spent to get to this $2.50 discount. So let's do some quick math. That means I have bought 75 shirts, and in buying those 75 shirts, I have spent $10, which means I've spent a grand total at this point of $750 plus $750. All right, that part is finished. Moving on. After you purchase 150, 150 is less than X. The price decreases to $5 per shirt. 5X, again, I'm going to be taking off this 150 now. Now I need to see how much money I would have spent. So 7.5 times 150 minus 75 plus 750 is equal to $1,312 and 2 quarters, 50 cents. 1312.5. This problem is finished. Now, I said to write a function that models the situation. It is not asking me to find an amount of charge. Okay? If it were, we would have to change that a little bit, which we're going to see in number 5. A rental home on Airbnb rents for $100 a night for the first 3 nights, $90 a night for the next 3, $80 for each remaining. The total cost T as a function of the number of nights, X, that a guest stays. Write the piecewise defined function T. T of X. All right. The first night, first 3 nights is 100 X. And with this 100X, this is from night 1 to night 3. Now then, I have a quick question for you. Actually, should be 0. 0 is less than X, less than or equal to 3. Now I have a question for you. If you went to a hotel tonight and you told them you would like to rent the room for an evening, for a night. So you buy the room, you go upstairs into your room, you get your stuff laid out, and at 11 p.m., you have to leave and go back home. Are they going to refund you your money for this room? The answer is no. You have already spent your money. They are not giving it back. You did not take the entire night. However, you still were in that room. You still paid them your money, and you are not getting a refund. So we have to do something special for this function. We have to make this a ceiling function for the variables. So those 2 symbols I just wrote are not supposed to be square brackets. It looks like partially a square bracket, because what this means is anything inside this square bracket is rounded up. So typically, your rounding up is 5 or more, raise the score. And this, if I have 0.001, this is equal to 1. If there is a decimal, you raise it up to the next number. That is what a ceiling function is. Okay. $90 a night for the next 3 nights. So 90, ceiling function of X. All right, we have stayed in here 3 nights, minus 3, where 3 is less than X, less than or equal to 6. And I about left off my y-intercept. How much money I've already spent. I've spent 3 nights in this hotel at this point, so I'm adding $300 to my total. All right. $80 a night, X minus 6, At this point, I have spent 6 nights. I'm going to plug this into my second equation. 6 minus 3 is 3, times 90 is 270, plus 300 is 570. And this is any night after 6. Now, let's look at this in Desmos, and then I'll let you do your practice problems and be done for the day. If I go into Desmos, I'm going to type my initial equations. 100x, if you remember from graphing, you put the curly bracket and then your domain constriction, 0 less than x less than or equal to 3. 90, x minus 3. Plus 300. Where 3 is less than x, which is less than or equal to 6. And lastly, 80, x minus 6, plus 570, where 6 is less than x. I'm going to change my axes now. Now I've went up to 6 days, so I'm going to make my x-axis from 0 to 10. That'll give me a little bit more than what I did in my problem, a little bit more days that is. I don't have negative money, so that's 0. And I'm going to go up to $1,000. Here's a picture of the graph. Now, as we have already mentioned, this is not accurate because I can't spend 1.11 nights. That would have to be 2. Well, how do I fix it? How do I make this a ceiling function? Well, here's how you do it. You type the letters C, E, I, L. And parentheses around the X. C-E-I-L. C-E-I-L. Here is my function. So up to night 1 is $100. After 1 night is $200. After 2 nights is $300. After 3 is $390. After 4 is $480, and so forth. And I can do this to infinity. So if I spend 300 nights in this hotel, okay, well I can't put it there, but that's 300. I can spend $24,090 staying here. Okay, that's how you do a ceiling function in Desmos. I do want you to try the 3 problems for your work for today, and that is all I have for you. I will post the answer key that you can have access to after you have submitted your work. All right, have a great rest of your day.